Mister, don't forget to actually pay this.
So we have actually one more section in this unit, but I'm going to split it up into 2 days. So this will be 1.7a. Basically, this unit, this algebra review unit, we were talking about how to solve problems, how to solve equations, how to solve inequalities. This section is all about a specific type of equation that sort of like puts a monkey wrench in everything we've been talking about. Today we're going to talk about absolute value equations. The reason why absolute value equations sort of throw a monkey wrench into our algebra knowledge is because once those two vertical bars go up, normal rules of algebra does not apply. So let's start off with like some counter examples, some bad things that you should not do. So these are things that you cannot, or rather, should not do. Right. Oh, people go, I know how to do algebra, inverse operations. So I'm going to plus 5 here. Cannot do that. Negative 2, absolute value of x plus 3 equals 7. Oh, I know that when there's a number in front of parentheses or brackets or whatever, I distribute that in. You cannot do that. So when those vertical bars go up, it really sort of screws up the rules of algebra. What about this guy here? Absolute value of 3x equals, 10. Oh, I'm just going to divide out the 3. You should not do that. So we sort of need a way to get rid of the absolute values. These absolute value bars, again, they get in the way of normal rules of algebra. To do that, we just have to use logic. We have to go back to our understanding of absolute value. So I don't know when you guys learn about absolute values, middle school, pre-algebra, but geometry. But if I asked you, hey, describe absolute value to me, what are some thoughts? Absolute value is ... Something about doing the opposite. Any other thoughts, ideas? Yes? It's distance from zero. That's the classic geometry definition of absolute value. Anyone else have anything new to add? Those are some common, typical definitions of absolute value, except the opposite bit. We're going to clean that part up a bit, but the very common, most quoted definition, it's the distance from zero. Why is that? Well, let's first talk about the idea of absolute value. And I think some people get this notion in their head about opposites because of the following examples. So consider, if you would so kindly, consider the following examples. If I asked you, what's the absolute value of negative 2? Of course, everyone's going to scream out at me. 2. What is the absolute value of, negative 7? Everyone's going to say 7. What about fractions? What is the absolute value of negative 3 over 4? Everyone's going to tell me 3 over 4. What about decimals? If I ask you what's the absolute value of negative 1.9, everyone's going to tell me 1.9. So this is where people sort of get the notion in their heads, oh, absolute value, that's going to be the opposite. But what if I do these examples? Absolute value of 5, everyone will tell me it's actually just 5. If I ask you, hey, what's the absolute value of 12, you should tell me 12. If I ask you what about fractions, absolute value of 1/2, everyone will should tell me 1/2. And what about decimals? What's the absolute value of 3.4? Hopefully people will tell me 3.4. And the reason being is because absolute value geometrically is the distance from 0. 5 is 5 units away from 0. Negative 7 is 7 units away from 0, so on and so forth. So the first definition, absolute value is the opposite, isn't 100% true, because clearly these last four examples did not take the opposite. As a matter of fact, it looks like the absolute value behaves in two different ways. The absolute value can indeed give me the opposite. So these examples here did give me the opposite. However, these examples here did not give me the opposite. It gave me the exact same thing right back out. So the formal fancy schmancy definition of absolute value what does this absolute value really do? It looks like it does two things. It can give me the same thing right back out. If I put in a 5, it gives me a 5. If I put in a 7, it gives me a 7. But it also could give me the exact opposite out. If I put a -2 in, I get the opposite, +2. If I put a -3 in, I get the opposite, +3 out. So the definition is actually piecewise. By definition, absolute value of x could equal the same thing, or it could equal the exact opposite. How do I know which option to use? It all depends on what we put into it. We get the exact same thing right back out if what you put into it is non-negative. And we get the exact opposite thing out if what we put into it is negative. So these math symbols, in case you're unfamiliar, greater than or equal to 0 is code word for not negative. And less than 0 is code word for negative. So just anytime you use inequalities with 0, you're either positive or you're negative. How does that help us solve equations? Well, let's do two simple examples, and then we'll sort of ramp it up to see how it applies. Bless you. Suppose I asked you to solve, and you can probably do this in your head, but I'm going to do it the formal way, the long way, just so you guys can see the idea. Suppose I ask you to solve absolute value of x equals 3. Right. Some people might say, but Mr. Vo, you've already solved it. The x is by itself. Not technically true, because the absolute value bars are there. We still need to get rid of it. Well, how do we get rid of absolute value bars? It's with this definition here. But the question goes, okay, Mr. Vo, but that definition uses two things. It could equal itself, or it could equal the opposite. Which one are we supposed to use? Let me ask you this question. This x here is a variable, yes? That means it could be anything we want it to be. So if I know for a fact that this particular x right here is positive, of course, it's going to equal itself. If I know for a fact that this x here is negative, I know he's going to give me the exact opposite. How confident are you guys in knowing exactly what this x is? In other words, if you're willing to bet money, no, let's not go that serious. If you're willing to bet like your life that this x is positive, would you take that bet? No, because by definition, it's a variable. We don't know what it is. So mathematically, we have to cover all bases. We have to go through all options. According to this definition, what could this absolute value of x equal? What could it equal? According to this definition. Well, no, according to this definition, it could equal a regular x, which equals 3, or according to this definition, it could equal negative x, which equals 3. Now we generated two separate equations without absolute value bars that we can solve like regular. Of course, this is trivial. This guy's already solved. In this case, in the second case here, we divide out a -1, and we get x equals -3. So yes, this, like I said, this was a simple example, but I want to do it the long way. That's how we solve this absolute value equation. We bring down the absolute value bars by applying the definition, and then we solve the later two equations. Now, I sort of want to go back to the definition that someone said. Hey, absolute values is just distance from 0. Let's visualize these solutions on the number line. And for once, I'm not going to do a lazy man number line. I'm actually going to draw tick marks. So 0, 1, 2, 3, 4, -1, -2, -3, -4. And our answers were +3 and -3. So plotting +3, -3, here they are. And not surprisingly, notice how they're equidistant from 0. So yes, absolute value of x equals 3, translated in plain English, means the distance from 0 is 3. What I want to do now is sort of like take a look at a different example, and we'll see how that logic, it's distant from 0, sort of changes a little bit. So scrolling up, we're going to solve a very similar example. But now I'm going to do x minus 5 equals 3. Right? Yes, we can probably solve this in our heads, but let's just, for the sake of notes, do it the long way, the proper way, so we can see the ideas. Remember this definition here? Recall that. If all the x's are too confusing, what is the most important stuff is this. By definition, if you take the absolute value of stuff, doesn't matter what that stuff is. I'm using fancy technical language here. According to the definition, we can get the identical stuff out, or we can get the opposite stuff out, depending on whether or not that stuff is positive or negative. But if that stuff contains a variable, we don't know if it's positive or negative because it could be anything, so we have to cover both bases. Do you guys see here how in this example, what's inside the absolute value, the x minus 5 contains a variable? So that means, guess what? I have no idea if he's positive or negative, so we have to cover both bases. According to the definition, if I put an x minus 5 inside of an absolute value, I could get the identical thing out, x minus 5, which so happens to equal 3. Or, according to the definition, if I put an x minus 5 in, I could get the exact opposite stuff out, which so happens to equal 3. Now I have two regular equations with no absolute value bars. The normal rules of algebra apply. Use inverse operations, solve, etc., etc., etc. So on the left here, add 5. That's pretty simple. I'm going to add 5. That gives us x equals 8. The right equation, there are generally two accepted methods. You can distribute the negative in, or what most people like to do is they like to divide out the -1. Either way you want to work it, it'll give you the same answer. I'll divide out the -1, gives us x minus 5 equals -3, and then when you add the 5, you get positive 2, right? So slightly different than before. In the previous example, the answer was positive 3 and negative 3. They were the same number, but opposite. In this case here, our answers were 2 and 8. Curious. Let's visualize the solution by plotting on the number line. I'm not going to make you plot on the number line for the homework. I just want to do this for notes. But let's see what this guy looks like. And again, I'm going to draw tick marks, try to be organized. Since I don't have any negatives, I'm not going to worry about, -1, -2. So I'll just start off at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't think we'll need that many because the answers were 2 and 8. This example that we just did is an example of absolute value. So the concept, the idea shouldn't change. If we take a look at the first example that we did, the super duper easy one, we saw that, hey, absolute values are special. It's distance from 0. We saw that when we plotted them, they were equidistant from a particular number. In this case, the two solutions were equidistant from 3. So I suspect my answer here should exhibit the same qualities. Are these two solutions equidistant from one single number? And if so, what number is 2 and 8 equidistant from? What is this right smack dab middle of 2 and 8. 5. We see that these two solutions are equidistant from 5. Well, how far apart are they from 5? 3 units. 3 units. Interesting. That means absolute value of x minus 5 equals 3 gave us two answers that were 3 units away from 5. Do you guys see the connection between the equation and the meaning behind the absolute value? Bless you. The solutions that we got, 2 and 8, were 3 units away from 5. Absolute value of x minus 5 equals 3 gave us two answers that were 3 units away from 5. Absolute value of x minus 5 equaling 3 tells us that answers are 3 units away from 5. Guys pick up the pattern already, just with one example? Yeah. So if I gave you absolute value of x minus 2 equals 7, conceptually, don't tell me the answers, conceptually, what does this idea is trying to express? These should be numbers that are this guy here, absolute value of x minus 5 equals 3, should be numbers that are 3 units away from 5. Therefore, by the same logic, this guy here should mean what? These are numbers that are 7 units away from 2. These are numbers that are 7 units away from 2. X minus 9 equals 12. Conceptually, what does that mean? These are numbers that are 12 units away from 9. Numbers that are 12 units away from 9. So that's all you're doing when you're solving an absolute value equation. You're just finding numbers that are a set number of units away from a middle number. So in general, absolute value of x minus some number, let's say c.
Is Lucky Stephanie?
I think so. I think that's her stuff in the corner there. X minus c equaling some other number. Let's use k. I think k is often used in math. In general, this means you are looking for numbers that are k units away from c. For simple problems, that means we can solve these in our heads. We just look at it. We just think about it. But of course, life isn't always that simple. They could give you very ugly, big-looking problems. Sometimes mental math fails. So the moral of the story is, if you are given simple equations like this, we can answer it in our heads. Absolute value of x minus 2 equals 7. Numbers that are 7 away from 2. What are those numbers? Give me two numbers that are 7 away from 2. 9 and negative 5. Boom. We answered that without writing anything down. 12 units away from 9. 21 and negative 3. Boom. We answered that without writing anything down. But what if I gave you something like this? Solve, for absolute value of 2x minus 3 plus 7 equals, 14. No, that's bad. 19. What the heck does that mean? what are the numbers that are 19 units away from, I can't even process it. There's just too many weird stuff here. So when your problems are weird like this, what we have to do is we have to change it back to the simple type. And the simple types were when the absolute values were by themselves. So that's sort of the goal. That's sort of the idea. If you want to solve an absolute value equation, isolate the absolute value, right? Don't try to subtract in and out of it. Don't try to distribute inside of it. Don't try to change the absolute value. Your first goal is to get the absolute value by itself. So every single absolute value problem I solve, in my mind, I sort of like mentally highlight it. It's as if it's like a shining beacon. So remember this because I have a horrible memory. Absolute value 2x minus 3. It's as if the 2x minus 3 was like highlighted. So your job is to get that blue colored absolute value by itself. So just by pure visual sake, if you look at the left-hand side, what is not colored in blue? The 4 and the 7. So guess what? That tells you as a mathematician, we need to get rid of it. And how do we get rid of it? It's just using regular, good old-fashioned algebra. So in your mind, you're going to think 4x plus 7 equals 19. So the way we solve it is we sort of treat the absolute value as a giant variable. And then this, I hope, should be stuff we can do in our sleep. Oh yeah, that's easy. Minus 7 divided by 4. Anyone can do that. So let's go ahead and actually solve it. So 4 absolute value of 2x minus 3 plus 7 equals 19. 4x plus 7 equals 19. We subtract the 7 first. And then we divide out the 4. The moment you get the absolute value by itself, we got to break down those absolute value walls. And the only thing that can break down the absolute value walls is the definition. And by definition, the absolute value could give me the exact same thing out, or it could give me the exact opposite thing out. And lo and behold, boom, you're done. You're home free. Just solve those two equations, and that's it. Bless you. So let's take a look at the left equation. Add 3 over, divide out the 2, x equals 3. To the right equation, again, you can distribute, or what some people like to do is they like to divide out the negative 1. Bless you. Either way is fine. 2x minus 3 equals negative 3. Add the 3 over, divide out the 2. X equals 0. We solved it. Question?
How would you do if there's a variable on both sides?
That was my next example. Yeah. So all of these were sort of the same structure. The variable was only on one side. And when the variable's on one side, it's pretty straightforward. Just isolate the absolute value bars, solve it like normal. Before we move on, any questions with this example? A good question was brought up. Hey, Mr. Vo, we know in Algebra 1, variables can show up on both sides. What if there are variables on both sides with absolute values? Well, if variables show up on both sides, you must, actually I learned a neat trick here. I can actually bold. You must check your answers. If your problem only has numbers on one side, assuming your math is good, you didn't make any math mistakes, whatever answer you get is whatever answer you get. But when there are variables on both sides, you actually have to check your answer because you might get what are known as extraneous solutions. Extraneous solutions are solutions that come up when you do good math algebra, but they just don't work with the regular problem. And how do you know if you have extraneous solutions? There's only one choice. You've got to plug it in and check. Other than that, Lewis, to answer your question, nothing changes. You have the same steps. Isolate the variable, or isolate the absolute value, and then apply the definition. So let's do one quick example here. Suppose I ask you to solve absolute value of 4x plus 10 equals 6x here. Oh no, I got x's on both sides. The first thing I want to do is isolate the absolute value. So you see how the absolute value is already isolated? So let's just go straight into the definition. According to the definition, we can get itself out, which equals 6x, or we can get the exact opposite out, which equals 6x. And then you just solve it like a normal problem. I'm going to subtract the 4 on the left equation. I'm going to subtract the 4x, divide out the 2, so you get 5 equals x. Here I'm going to divide out the negative 1. I'm going to add the 6x over, gives me 10x, subtract the 10, divide out the 10. So in terms of my math steps, inverse operations, we did everything correctly. But since there's x's on both sides, we should really check. And to check answers, you just plug it back in. So to check x equals 5, just plug it back into the original equation with the absolute values. Absolute value of 4, 5 plus 10 equals question mark 6 times 5. Notice when I substitute, I use parentheses. 4 times 5 is 20 plus 10 is 30 equals question mark 30. Is it true that the absolute value of 30 is 30? Yes. That's a good answer. We keep it. Let's check x equals negative 1. So absolute value of 4, negative 1 plus 10 equals question mark 6 times negative 1. So 4 times negative 1 is negative 4 plus 10 is a negative 6 equals question mark negative 6. Is it true that the absolute value of negative 6 is negative 6? No. So this answer of negative 1 is bad. We throw them away. You only have one answer in this problem. Okay. Now, every time I teach this, kids, you guys make up shortcuts in your head, sometimes good, mostly bad. Most kids go, oh yeah, so whenever I solve this, if I get a negative answer, I'm gonna be lazy. I'm just gonna throw it away. Yeah, 9 out of 10 times, if you get a negative answer, it's most likely bad. But I still want you to check it because there are examples where if you get a negative answer, it might actually be a good answer. So get into the habit of checking when you're in these situations. You guys okay with that? One last thing I need to talk about, special cases. We know, that absolute value of stuff, it's distance from 0, right? It's always positive, or rather should say always non-negative. You know how when we solve linear equations, you have one of 3 possibilities? You can either get an answer, you can get no solution, or you can get all real numbers. When it comes to absolute value equations, there's only one special case, and that's no solution. If you get absolute value of stuff equaling a negative, well, conceptually, that doesn't make sense because an absolute value will never ever equal negative number. So if you get absolute value of stuff equals negative, you get no solution. For example, I'm just going to make this one up really quick. 2 absolute value of x minus 4 plus 7 equals 5. Let's say we solve this one. Okay, subtract the 7. Divide up the 2. At this moment here, you should just put your pencil down and stop. Actually, no, don't put your pencil down because you need to write. But just stop solving. You don't have to do the definition, and as a matter of fact, if you do, you can get it wrong. The moment you have absolute value equaling a negative, you are done. The answer is no solution. Right? So just keep that in mind. Save yourself a lot of headache. If you get absolute value, it has to be by itself. The absolute value by itself equaling a negative, you are done. No solution. Okay? All right. So today's practice, it should be more of the same stuff we have been doing all review, solving equations. That's the main thing of Algebra 1. Except I want you to apply the definition to tackle the absolute value case. That's it. That is 1.7b. Have at it.